This is the meaning. The first meaning of this is f is a function of r. This is single variable calculus. You have to wait till Calc 3 for multivariate. Okay? So in this class, we only deal with functions that have one variable. So in that case, I can even write this for clarification. I have GMM times r to -2. These I don't care because they're constants. So then df over dr will be -2, blah, 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 times r to -3. G, M, and M. You can rewrite it as 2GMM over r to the third. Is this okay so far?
Yes.
So what is the meaning of df over dr in the concept? Okay, so it's the rate of change of the magnitude f of the force, so magnitude, the rate of change of the force f, right, with respect to the distance between the bodies. So let's see what they want here. I never like the multiple choice. What is the rate of change of the mass? No. What is the amount of force? No. Change of the distance? No. Rate of change of the mass? No. Rate of change of the force. Rate of change of the force with respect to the distance between the bodies. So all these are nothing, useless. So df over dr represents the rate of change of the force very clearly with respect to the distance r between the bodies. What does the minus sign in the expression indicate? It indicates that it's decreasing. So the minus sign indicates that as the distance between the bodies increases, the magnitude of the force increases. No. The minus sign indicates that the bodies are being forced. I remember, I have to stop for 1 second. There was 100 years ago when I went through the driving test, one of the questions was, if it starts snowing, one of the answers in the multiple choice, if it starts snowing and you can't see and so on and so forth, what are you going to do? Pull over and wait for spring to come by? So please don't pull over and wait for the spring to come by, please. Okay, sorry about that. I had to say it. Sorry. Okay, the minus sign indicates that as the distance between the bodies decreases, the magnitude of the force remains constant. The minus sign indicates that the force between the bodies is decreasing. Okay. No. The minus sign indicates that as the distance between the bodies increases, the magnitude of the force decreases. Yes. Okay, and then suppose it is known that the Earth attracts an object with a force that decreases at the rate of this. When r is this, how fast is the force changing when r is 10,000? So the attractive force increases at the rate of 4 newtons per kilometer. Also, we have to be very careful with, so the radius, how fast does the force change when r is 10,000? So they are giving us this information, the 4 for the force and the 20,000 kilometers, to determine that constant, GMM. So let me copy this. So when, okay, it decreases the rate of, so df over dr equals minus 4 newtons per kilometer when r equals 20,000 kilometers. And how fast is so df over dr when r equals 10,000? Okay, good point. So let's take a look. So we do have the formula for df over dr. So the rate of change of force with respect to distance between the bodies is this. They are telling us when the force, when this side is -4, and this side is -2 GMM over r cubed, they are giving us the radius or the distance, 20,000. This is specifically given to us to determine this constant. Okay, there are 3 different constants, but all I want is one number. So I will cross multiply and divide by -2. So of course, I can multiply both sides by -1. So 20 times 4, so GMM is 80,000, or I can simplify here, and this is even better, 40,000. And these are constants. So this was in Newton per kilometer, and this is in kilometers. So when I multiply, I get newtons. So it's Newton.
We can't see your paper.
Oh, I talk too much. Thank you. Gee whiz, for 5 minutes I was showing here and nobody said anything. Only one student is paying attention? I hope not. Okay, I have to start from scratch now. So dF over dr is given to us as -4 newtons per kilometer. So this piece here, this one, is -4. This -4 equals -2 GMM, and they're telling us, oh, I forgot. Okay, so I have to do this again. So we have -2, -4 here, -2 GMM over 20,000, but it's to power 3. Okay, so this information is given to us to find GMM, this product. So I have 20 cubed times 4 divided by 2. So let's do that. I'm going to go to the next page. It's not clear here. And because I talk too much, I didn't copy the cube. So, okay, that's done. So let's take a look. We'll continue. That's my page 2. So then I have G times M is 4 times 20,000 cubed divided by 2. So this is, let's see. So 22 to the third is 8. 8 times 2 is 16. But I have 1, 2, 3, 4. So it's 10 to the fourth also to the third. My goodness. Times 10 to the 12th. And now this is measured in newtons per kilometer. This is measured in kilometers cubed. So then when I multiply by kilometers cubed, this becomes Newton per kilometer squared. But what they're really asking us to determine is dF over dr when the radius is 10,000. And now this is a piece of cake because we have dF over dr, which is -2 multiplied by this, divided by 10,000, also cubed. Okay, so let's see what this is. So -32, this is 10 to the 12th, and this is 10 to the 4th, also to the 3rd. So that's 10 to the 12th. So force divided by radius. So this is -32 newtons per kilometer. It was a very interesting problem. Thank you for bringing that up. Do we understand each step? Is it clear, Rick? Is it okay?
Yes.
Other questions? Anything else you worked on? Anything else you need help with? Just anything before we go back to 3.9. Okay then, so I'm going to share my screen and this time go to the book, and we are looking at 3. Why am I in chapter 2? Why can't I click on what is going on here? Why can't I go to chapter 3? Okay, what if I have to start from scratch? If you have tips for me, please let me know. Okay. Okay, so this the first problem we looked at, I don't remember which one it was. This one. Okay. Okay, so let's take a look at 7, and then we'll look at others. So in 7, it says a cylindrical tank, okay? Cylindrical tank. They say cylindrical tank, I have to draw one. As I said, we are dissecting every word, every piece here. With a radius of 5, which means it's always 5. So I will write immediately that this, which is the radius, is 5. And of course, immediately the measurement unit. And it says 5 meters, fine. Is being filled with water at a rate of 3 cubic meters per minute. I cannot move on before I identify what this is. Because if I don't know what this is, I will not be able to write anything. Can anyone give us what this is? Anyone? Give it a try, please. It's okay if you're wrong. Anyone? If we don't know what this means, then we can continue. That's crucial. Anyone would like to give it a shot? What can it be?
Is it volume?
Okay, but it has 2 measurement units. It cannot be just volume.
Is it the rate of change?
Yes, of what?
Volume to time?
dv over dt. Awesome, that's what it is. The rate of change of volume with respect to time. Great job, thank you. Good, I'm sharing again. How fast is the height of the water increasing? So we expect a positive number. And we're talking about how fast is the height of the water increasing. So we are putting water in it. And let's say this is the height. So what are we asked to determine?
How fast? The time?
So, but time will pass no matter what, right? How fast is the height of the water increasing?
The length?
So what do I have to write here?
Height?
One more time. Let's do it again. This is very important. That's why we're spending so much time on it. How fast is the height of the water increasing?
Velocity?
Correct, but for what? And how do I write it? Anyone would like to give it a shot? How fast is the height of the water increasing? What do I have here?
dv. The velocity, right?
How fast is the height of the water?
Oh,
dH over dt?
Brilliant.
Yeah.
How fast is the height of the water increasing? Awesome. Perfect. So where is our starting point? So we dissected everything. We have a figure. We have the radius. We pictured the height. The water is increasing, increasing, increasing from 0 up, 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 up till a certain point. So they are giving us dv over dt. They're asking us to find dh over dt. So where is our starting point?